Alright, welcome back. We're going to be finishing up Chapter 6, Section 6 today on graphing systems of inequalities. So we'll do a quick review of how to graph a basic inequality. In letter A, before you graph, I find it easiest to solve for y. So we have y is less than negative 8x plus 6. So now I'm thinking of the equation y equals negative 8x plus 6. And if I make a table of that, 0 would give me 6, and then I would be going down by 8. So 1 would give me negative 2, and 2 would give me negative 10. So if I come over here, 1 gives me negative 2. Hold on here. 2 is negative 10. And 0 gives 6. So I've got a somewhat steep, because the slope is negative 8, line with a negative slope, like so. But the problem is it would not be a solid line because I do not have an equal to underneath there. So I need to go back and make this dotted. So that is a dotted line. Maybe I'll make it dotted with blue. So it's not a solid line. The numbers on the line are not solutions. And then it says is less than. So that means we're shading down to the ground. So since it's a negative, my is less than side is this. All right, for my next one, again, I'm going to isolate the y. So I will subtract 3x. So negative 2y is greater than negative 3x plus 10. And then we're going to divide by negative 2. Whenever you multiply or divide by a negative, you flip that inequality. So 3/2 x minus 5. So I'm going to think about the equation y equals 3/2 x minus 5. So 0 would give me negative 5. And as I go over 2, I go up 3. So I'm going to not even plug 1 in because I'll get a decimal. Not a bad decimal, 0.5, but no big deal. So I'm going to go up 3 every time I go up 2 in the x is 3 in the y. That's how we get the 3/2. So 4 would then give me 3 more, which is 1. You could also take the 4 and literally plug it into the equation and solve. So 3/2 times 4 is 6. 6 minus 5 is 1. All right, I'm going to graph this one on red over here. So 0 is negative 5, and 2 is negative 2, and 4 is 1. Again, I don't have an equal to underneath this inequality. So I'm going to make this a dotted line. And then it says y is less than. These are both less than, so I'm shading below. And what today's lesson is all about is if I had to find the place where a and b both have a solution, that would be right in here. It'd be everything where it's double shaded. Okay, maybe I'll do this in green. Okay, so it's nothing on this dotted line, but it's right below it. And it's nothing on this dotted line, but it's right below it. And it's everything in between. So this green area is actually where both of them are shaded. I'm going to actually skip the next one because I've made a complete mess of this, and we will go forward. So the question is 0, 1 a solution to both of these? So I can, maybe the easiest way is just to plug it in. Plug 0 in for x and 1 in for y. So if I plug 0 in for x and 1 in for y, is 1 less than 2, so it's a solution for that one. And then if I plug 0 in for x and 1 in for y, is 1 greater than negative 1? So it is a solution for that one. So the answer is yes. So we could actually write a bunch of solutions that make this work. This is only one solution. If we were, I'm not going to graph them because we're going to graph a bunch in a minute, but if we were to graph them, we would get that double shaded region, and every ordered pair in that double shaded region is a solution. So if you look at this, we have the dotted red line and the blue line, and this green area is where everything is double shaded. So every ordered pair in that area is a solution. And then the same with this. We have the dotted blue line and the solid red line. They cross at this point right here. So everything in the green region is a solution. So you basically graph each inequality, shade them as you should, and then you darken where it is doubly shaded. All right, so let's practice this. X is less than 3. So you think about x equals 3. X equals 3 is a table where x is always 3. Y can be anything. So x equals 3 is a horizontal line, or vertical line at 3 over 3 up 0, over 3 up 1, over 3 up 2. Because it's less than, it is dotted, so it is not solid because there's no equals to. And then it's less than, so we're shading everything towards the negatives. All right, this is lovely. This is already solved for us for y. So if we think about a table for y equals x minus 2, 0 would give us negative 2, 1 would give us negative 1, 2 would give us 0. So 0 is negative 2, 1 would give us negative 1, 2 would give us 0. And a really good point to always have is the point where they cross. So see how 3, 1 is shared in both of those? So that is a very good point to include in your graphing. All right, this time we have another dotted line because there's no equal to below that inequality. So that's my straight dotted line. And then it says y is greater than, so we're shading towards the positive, towards the sky. So my double shaded region is right here. So the ordered pairs that lie on the dotted lines are not solutions, but everything in the red shaded region is, and right next to the dotted line. And it would also be a good idea to test. Like you could plug in 0, 0. That's a point that's in the solution and make sure it works. Is 0 less than 3? Yes. Is 0 greater than negative 2? Yeah. So, good. Okay, this time we have y is greater than 2x plus 3. So we're going to think about y equals 2x plus 3. We're going to remember to make it a dotted line. So 0 is 3, 1 is 5, 2 is 7, and so on. Now if you look at these two equations, what do we notice about the slope of them? That they're the same, they're parallel. So these are probably never going to cross each other. So I'll graph my dotted line here. Okay, make it a little thicker. And it's greater than, so we're shading above towards the sky. All right, my next one is y is less than 2x. So I'm thinking about y equals 2x. 0 gives 0, 1 gives 2, 2 gives 4. So do you see how these are perfectly parallel, no intersection point at all? And then this says y is less than, so I'm shading below. Now there is nowhere that these are double shaded. So this actually has no solution. There's no ordered pair that satisfies both of those equations because they're shaded in the opposite direction. If they happen to be shaded towards each other, the solution would have been right in between those two dotted lines. All right. So I'm thinking y equals 2x plus 4. 0 gives me 4, 1 gives me 6, 2 gives me 8. If you can also do this by just starting at 0, 4, and then knowing the slope is 2, over 1 up 2, over 1 up 2, that's totally fine. And then we have a dotted line because there's no equal to. And then we're shading above because it's greater than. Now I need to isolate the y before I can make a table of this. Unless you want to get your x and y intercept, I think it's easier just to look at it in y equals mx plus b. There's always more than one way to do things. So now we're going to divide by 2. We're not dividing by a negative, so no flipping occurs. So 0 gives negative 1. 1 is going to give negative 4. 2, negative 7. The other tricky thing, if you're just doing the x and y intercept, is that you don't really look at this and think it's a negative slope. Like, you have to go through the steps in your head, or at least I do, of how to solve for y to make sure your graph is making sense. Alright, so this time we have a solid line because of this equal to right there. That means solid line. We could figure out the exact point that they cross through substitution or elimination if you want. And then it says y is greater than or equal to, so we're shading above. Now you can keep shading this, or you can stop, and then you just need to make sure you extra darken this whole region where the double shading is. And you can test a number if you have time and make sure it works. So in this case, like 0, 1, 2, 3, 4, 5, 6 looks like it's a solution. So if I plug 0 and 6 in, that one works. And if I plug 0 and 6 in, that one works. So that's a good sign that I did something right. And it only takes a few seconds. Okay, this last time we're going to actually write the inequality. The shading's a little hard to see. So let's say that this one is shaded right here. Let's say this one has double shading, since the other one we didn't. And then let's say this is shaded above and below. We'll go with that. All right. So the first one here, I'll do the red one in red. We have a y-intercept of 1, and then we have a slope of 1, over 1, up 1, over 1, up 1, because these are going up by 1. So that red equation is y, and it's not equals, it's shaded above. So it's y is greater than, and it's not equals because it's dotted, and then 1x plus 1. The last one is because of that b being 1. Now our blue line should have the exact same slope, up 1 over 1, but our blue line has a b at 1, 2, 3. So our blue line should be y, and then it's shaded below, so y is less than 1x plus 3. So that system of inequalities graphed is the solution that you see written. In our next one, these are horizontal lines. And horizontal lines, if you look at the blue line and you think about a table of it, we have 0 giving us 4, 3, 1 giving us 3, 2 giving us 3, 3 giving us 3. So you see how y is always equal to 3? So this horizontal line is y equals 3, but it's not only equals 3, it is equals because of the solid line, but it's also shaded above. So its y is greater than or equal to 3. And then the red line is a horizontal line at 1. So that would be y, something with an equals to 1. and this one shaded below, so it would be y is less than or equal to 1. So our system of equations for the second is right there. All right, I hope that was invigorating and made complete sense. I'll see you tomorrow.